Hello everyone and welcome to Module 5, where we will finally delve into the nitty-gritty of designing a research study. Specifically, we will be talking about sampling and measurement, two very important aspects of any study. So let's begin with sampling. Sampling refers to identifying and selecting your sample of participants. This may seem fairly easy when you first think about it. If I want to study workplace health hazards for construction workers, I'll simply put out an ad for construction workers to participate and take whoever calls me, right? But what types of construction workers are you interested in studying? Those who operate heavy machinery? Those working at urban work sites? Who is most relevant to your research question and hypotheses? Where will you put up your players? Will they put up your flyers, I mean? Will they attract a group of construction workers who are representative of all construction workers? When they call in, how will you decide whether they and the study are appropriate for each other? Will you have enough participants? All of these are questions that we must ask ourselves. So when deciding on sampling procedures, we have to consider who we're trying to study, which is the target population, where and how to find those people who are part of this population, whether our sample will be representative of who we're trying to study, and finally, how many participants we will need to include. First, let's talk about how you're figuring out whom to study. So you already know who your target population is, because this should be already in your research question. Remember the exposure plus disease plus population formula? Well, the target population is simply the general group of people that you seek to understand. This can be a very specific group, say newly hired male elementary school teachers in Providence, or more often the group is more broad, say American kindergarten students, and that's what we're going to talk about in this example. Since you will not be able to study or even try to get in touch with every single American kindergarten student, you will need to find a source population, which is the pool of individuals from which you plan to recruit your study sample. At this stage, you already need to be careful that your source population is representative of your target population. You wouldn't want your source to be a private kindergarten in Beverly Hills because the children there are likely not typical of the full range of kindergarten students across America. Also, your source population selection should be practical. Don't choose the perfect elementary school in Arkansas if you're conducting a time-intensive experimental study in Rhode Island. More appropriately, you may identify one or several public kindergartens near you that has a demographic makeup more similar to the general American 5-year-old population, but it doesn't have to be absolutely perfect. Depending on the type of study you're doing, you may ask everyone in your source population to participate, say by putting up flyers at the elementary schools or sending an email invitation to all kindergartners' parents in those schools. This is more likely if you are conducting a survey study that is feasible to administer to a large number of participants. But if you're doing a time and resource-intensive experimental study, for example, you will need fewer participants. In that case, you may only invite a portion of the whole kindergartner population of, say, the county to participate. But how do you go about this in a practical and scientifically sound way? The best ways to approach the selection of the sample are to use probability sampling methods. Essentially, these methods select individuals randomly from the source population. For example, by using a computer to randomly select a number of kindergartners from the school's database. This is called simple random sampling. Or if it's a really big school system, and say your research question involves classroom interactions between kids, you might randomly select whole classes to participate. This is called cluster sampling. The major advantage of these probability sampling methods is that they minimize bias in who ends up in the study and who doesn't. Why is this important? Well, imagine your experiment tests whether a computer game can generally improve kindergartners' reading skills. Instead of randomly choosing kids to enroll in the study, we could simply put up a flyer in the school saying, "Learn to read with an experimental computer game." But then we might end up with a lot of participants who are really poor readers, poorer than the average kindergartner, whose parents are desperate to try anything at all, or say the kids already love to play video games and that's how they learn their math and their other things too, and they're really used to playing computer games. So then when we find out at the end of the study that our computer game did help our sample of kindergartners with their reading skills, can we really say that this game can help kids in general, or only those who are particularly struggling with reading, or those who like to play computer games already? This is a major problem with self-selection bias, in which the participants you end up with are not representative of the general population because they were more likely to choose to participate. Another simple example is, say, recruiting for your study about exercise at a marathon finish line. The participants you'll get are already exercisers. Can the findings from your study really apply to everybody else too? So this is a major problem with potential self-selection bias. There could also be bias on the part of the researcher. Imagine that you have a particular affinity with 5-year-old boys who like to read because you have a favorite nephew who is 5 and likes to read. Without even knowing it, you could be recruiting more participants that fit this particular bill than is proportional to the target population, skewing your sample towards males who like to read, again making your sample non-representative. However, sometimes it's not feasible to do probability sampling. For example, you might be trying to do a case control study to examine exposure histories in kids with Duchenne muscular dystrophy. If you haven't heard of this study, or this disease rather, don't worry because it's a very rare childhood disease. Because it's so rare, you probably won't find enough participants with this disease if you simply randomly draw from a school database. In this case, we need to do convenience sampling, which is recruiting based on access to the individuals you're looking for. So in this case, you may specifically go looking for children with Duchenne at, say, a specialist's office, but be very careful with convenience sampling approaches. It is not necessary or appropriate for study approaches such as the cross-sectional survey, an approach where it's especially important to have a representative sample. The convenience sampling approach is actually often abused for the sake of, well, convenience. For example, social psychologists have come under a lot of fire for almost always using college students as their sample, and then drawing conclusions that they claim apply to people in general. So instead of claiming that people cooperate more when they're in a good mood, for example, the claim should be mostly white and upper middle class Ivy League Psych 101 students cooperate more when they're in a good mood. So do not make the same mistake when you do your sampling. At the end of the day, no matter what sampling method you use, the goal is to end up with a group of people that are representative of the target population you wish to understand. So not everyone who calls in about your study will be a good fit. For example, if you're testing a binge drinking prevention program for college students, you will need to turn away potential participants who are not college students since they wouldn't be representative of your target population. This requirement of being a college student is thus an inclusion criterion, a characteristic the potential participant must have in order to participate. You might also have to turn away potential participants who already have a binge drinking problem, since you are testing a prevention program. This is an example of an exclusion criterion. Often, clinical trials will exclude participants with a certain set of characteristics that the researchers think could introduce extraneous variables, or those that can increase risk for the participant. For example, I'm currently recruiting for an exercise intervention study for those with Parkinson's disease. I must exclude those with significant walking difficulties because my intervention may put them at higher risk for falling. Ideally, you want to have as few exclusion criteria as possible because the more restrictions you have on those who make up your sample, the less representative your sample will be. There are many more guidelines and tips for sampling depending on the research approach that you're taking. When we get into the specifics of each approach in Modules 7 to 9, we will talk more about those. For now, let's finish up sampling with a brief discussion on how to determine the sample size you need. Just like Goldilocks with the 3 bears' possessions, you have to find the sample size that is not too big, not too small, but just right. Too big of a sample can be cumbersome and wasteful of resources, though this is rarely a problem in real life because science research budgets don't tend to allow this to happen. Too small of a sample means that you won't have statistical power to find an effect with a good level of certainty or confidence. The sample size must be just right, based on statistical estimations about how many people are required to answer the study question at a specified level of certainty. If you must, you want to err on the side of having a bigger rather than smaller sample. This is because bigger samples tend to yield group means closer to the true mean of the population, because bigger samples tend to be more representative of the population. In other words, you'd ideally like to find out the average amount of vegetables consumed by all teenagers, for example, but since you can't survey every single teenager in the world, you have to trust that your sample of 100 teenagers, say, are representative of all teenagers, and that their average level of veggie consumption is pretty similar to that of all teenagers. However, if you only had 10 teenagers surveyed, there's much more risk that your sample is not representative, and some freak bias made it so that these 10 teenagers on average consume, say, a lot more vegetables than teenagers in general. Because of this higher risk, your findings will have less confidence attached to them. In other words, the data you get from this sample, the small sample, have much less power to confidently draw a conclusion. To be perfectly frank, when it comes to deciding on a specific sample size, there are no hard and fast rules to help you. It depends on the study approach. Cross-sectional surveys need many more participants, for example, than case series. You can use sample size calculators that are freely available online or those that come with the other statistical software. So for example, you can use powerandsamplesize.com/calculators. I'll put up the link in the module for you to try it. So you might ask, why do I need to decide on my sample size before I start my study? Why don't I just start recruiting and stop when I have enough power to find an effect? Nope, you cannot do this. Imagine if every researcher just kept enrolling participants until their findings became statistically significant, or they stopped short of the planned sample size as soon as their findings became statistically significant. Then we would only have significant results in science, no matter what the hypothesis. This is basically the same thing as researchers handpicking the results that they like from their study and ignoring the ones that they don't like. They would end up with results that are not representative of the truth, even if these results are what they like to see. To review, sampling involves first defining your target and source populations. That is, whom you're trying to understand, and a subset of this population that you can recruit from. Then you will need to identify, preferably using probability sampling methods, a sample population. While recruiting and selecting your study sample, you must make sure to minimize risk so that you end up with a representative sample. You will also need to screen out relevant characteristics that would introduce extraneous variables that could affect the results that are not your main independent variable, or increase the risk for participants. It's also important to remember to estimate your sample size before you begin, again to minimize bias. At the end of the day, you want to end up with a sample that is representative of the target population and a sample that will have the lowest risk of introducing bias into your results.